Hi everyone, welcome to another section in chapter 7, costs in the long run. This is our last segment where we round out the whole long run average cost curve. So we're going to talk about the long run and diseconomies of scale, or decreasing returns to scale. We saw economies of scale, or increasing returns to scale. We saw constant returns to scale, and now we're going to look at decreasing returns to scale, or diseconomies of scale. Then we'll put the entire long run average cost curve together and have a good long look at that, and then introduce a new concept called minimum efficient scale. So what is diseconomies of scale, or decreasing returns to scale? You can use those two terms interchangeably here. And it's basically where a firm's output, as it says, increases, yep, but by a smaller percentage than the inputs. So if the inputs are doubled, the outputs are, well, not doubled. If the inputs are increased by 90%, well, the outputs only go up less than 90%. So that's just how we look at it. And bureaucratic inefficiencies are often the reason for this kind of thing. Now, they're not a bad thing, but they often result in decreasing returns to scale. So a small example that I personally experienced is there was a company I knew of, and I used to be a price forecaster. So I'd sit down and we'd have these price forecast meetings every day, try and guess where the price of the different commodities were going to go. And I was the one charged, unfortunately, with putting all the information together. Everyone else got to argue with me. And then in the end, we'd make a recommendation that probably wasn't the one I would make anyway. But the key point I'm trying to make is someone would lead down the hall and yell out the door, "Hey, boss, can we put on this trade?" And he'd say, "Keep it to 100 grand, go ahead." So we'd execute the trade, and all that would happen within an hour. But then that company that had a really good name for being an awesome bunch of employees, of course, got bought out by a much bigger, much slower company. And they'd still have their price forecast meetings and still look at putting deals on, but then someone would lean back and the manager was right there at the table, and he'd shrug his shoulders and go, "Yeah, that sounds good. Let me take it to my boss." And they'd write it up on a piece of paper and it would go to his boss. And then his boss might be a little bit concerned. So he'd take it up to a higher level. And by the time everyone rubber stamped it and gave it their own approval, the opportunity was gone. So bureaucratic inefficiencies, that wasn't a bad thing, because you don't want a bunch of people sitting down there making rogue trades that could sink a company. Bigger companies want a little bit more security and possible conservatism. So it's not a bad thing. It's just that they got bigger and you run into these decreasing returns to scale, or diseconomies of scale. So let's go ahead and draw our graph. We start out with plant 1, or AC1, right here. And we say, okay, that's a short run cost curve, and its economic capacity is right there, 1,000. So that's the lowest average cost in the short run. There's its economic capacity, and we see the average total cost is 40. And then the story goes, the manager comes out and says, "Hey, let's double our inputs and see what happens." So the engineer goes away, comes back with the graph, draws the graph here, and says, well, when you doubled your inputs to go to plant size AC2, or doubled your total costs, which is essentially the same thing, you know what? Your output didn't quite double. At that economic capacity point, your output's only 1,600. It started out 1,000. So that means your average total cost on average of production went up. Okay, so if you've doubled your inputs and you don't quite double your outputs, or if you increase your inputs by 80% and your outputs increase by 60%, that's diseconomies of scale. And we end up drawing the long run average cost curve now by connecting these dots from there to there. And you can see the rising long run average cost curve refers to diseconomies of scale, or decreasing returns to scale. So let's look at another way to calculate these kinds of things. I mentioned in the previous slides we did it two different ways, and now we're going to do it by looking at percentage changes, and it'll show us constant, economies, or diseconomies of scale. So there's 4 examples here, A, B, C, or D. The way you calculate the percentage change in inputs is you just go 12 minus 6 divided by 6 times 100, and you'll see that that is 100%. The percentage change in output, you do the same thing. 480 minus 240 divided by 240 times 100. So when you calculate that, you'll see that's also 100%. So rather than kind of grunting through all the numbers, I'll just click ahead, and there we go. Inputs increased 100%, outputs increased 100%. So that's definitely constant returns to scale. Keep in mind, it's no different if we had calculated inputs went up 38.1% and outputs went up 38.1%. That's still constant returns to scale. So what does the next one look like? C. Well, in C, it shows, just one sec, that, B, I'll get it right. Inputs went up 100%. So that's basically going 92 minus 46 divided by 46 times 100. Inputs went up 100% and outputs went up 650 minus 275 divided by 275 times 100. Outputs went up 136%. So that's economies of scale. We had an increase in inputs of 100% and the increase in outputs were much greater. So that's economies of scale, and we'd have a downward sloping cost curve because the average cost of production is falling for economies of scale. So what does the third one show us? C says inputs increased 50% when they do the calculation. I'll let you figure it out. And outputs increased 60%. So that's still economies of scale. Inputs went up 50%, or the cost of inputs went up 50%, and outputs went up 60%. So that's economies of scale. And then the last one, you can calculate the percentage change there. Here it's 540 minus 260 divided by 260 times 100. So inputs went up 108%. And outputs, well, 2480 minus 1240 divided by 1240, I can see that that's up 100%. But because inputs went up a greater percentage than outputs went up, the engineer says, you know what, our average total costs are going to rise. That's diseconomies of scale. So we calculated 4 separate ones here. We got the three scenarios: economies, diseconomies, and constant returns to scale. Now we're going to look at what might change some of our costs in the short run and the long run. Well, anything that changes costs in the short run has to change costs in the long run because they're joined. If you remember, if I draw my big long run cost curve like this and all my little cost curves here, if there's a technological improvement that comes along, so to speak, that reduces the cost of production, well, that's a short run thing. So short run costs go down, but because they're attached, long run average cost curve also goes down. So I'm just going to draw the long run. It would drop, and so do all the little short ones drop, because anything that changes costs in the short run changes it in the long run as well. What else can change costs in the short run? We talked about that in the last chapter. Remember, total costs are made up of fixed costs or variable costs. So if somehow you can negotiate a lower fixed cost, say a rent, then along the whole planning horizon here, your short run costs would drop, but then so would your long run. And just like if you can negotiate lower salaries, then you do your scenarios of the different plant sizes, you calculate all those costs with a lower salary cost. So the whole curve would drop down. So anything that changes in the short run costs will change the long run as well. Okay, now we tie it all together. Why did we do these 3 separate things? Well, it's because if we put them all together, we get a nice picture of what a company could go through. Not all of them ever go through all these things, but they really just to show different stages that companies might be at. So here's economies of scale, and here's all my short run curves. My little red short run curves, there's many, many down there. I'm only drawing a few. Because they're all falling as we increase output, we say that's economies of scale. We're getting, when we connect them all on the purple line, we're getting a downward sloping long run average cost curve. That's because we increase our plant size, increase our inputs, and we more than increase the outputs. The factor increase is greater than the factor increase in inputs. Then we reach this point where different size outputs or different size companies all seem to be at the same long run average cost. And that's called constant returns to scale. And then sooner or later, you run into diseconomies of scale, where you run into those bureaucratic inefficiencies and the average costs start rising again. So in this case, you say, well, we double the inputs, but we less than double the outputs. So diseconomies of scale, or decreasing returns to scale, economies of scale, or increasing returns to scale, and constant returns to scale right in between, where different size plants have the same level of average total costs. So let's take this a little bit further and explain why that might be useful. But before we go there, I want to talk about a short run and a long run phenomenon using this graph. Drawing the short run phenomena again, there's my average total cost curves in the short run. So I know this spot on that one, if I come down, that's economic capacity in the short run, remember? Let's go to the third one and I go right to the bottom here. That's economic capacity. Well, if I have a few more along here, all of those will have their economic capacity. All these short ones will have economic capacity. I'll draw the last one there just to round it out nicely. Those are all short run. Everything that's red here is short run. So the minimum levels of all these curves are short run economic capacities. How many have I drawn? Well, think about that. A new definition that we want to talk about is something called minimum efficient scale. And that's where you reach the lowest long run average cost. So right here is where I've reached the lowest long run average cost. I'm going to put one more curve in here. There's this short run cost curve. I'm going to make it really big so it stands out. Reaches there. The bottom of the red line, well, that's another Q economic capacity because that red curve is short run. But then when we switch our brains to think of the long run, this green dot, that's called minimum efficient scale. It's the first time we hit our lowest long run average costs. Now we're going to look at that a little bit later, but if I ask you how many economic capacities do you see, you first think, well, those are short run things. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 short run curves. So there's 12 economic capacities on this graph. How many MESs, how many minimum efficient scales? How many times do we first hit the lowest long run costs? And that answer is just once, right there. Okay, like I said, we're going to take a closer look at this in a bit, but before we go there, we're going to look at one more slide to kind of explain the period it takes to reach our MES, or how long do our economies of scale last? Well, different industries have different economies of scale. And great big assembly line type of industries like automobile production or cable TV or cell phone towers or pipelines themselves, great big assembly line type of production facilities, well, they take a lot of quantity, a lot of output, and average costs keep falling and falling and falling until they get really, really big. So they've got a huge period of economies of scale before they reach MES, minimum efficient scale, and then they turn around and start showing increased costs. Okay, so we gave some examples of those types of companies that go through this, petrochemical companies, things like that get really, really big and achieve long run economies of scale for a lot of output. Then there's others that really quickly hit MES. Right there is MES the first time you hit lowest long run curves. And then a bunch of companies can all compete with each other, at least on cost, because it appears that even if they scale up size, they have the same minimum long run average costs. And those are kind of things like they show computer software developers. So I can have 3 brilliant developers and a really small quantity output, or I can maybe have 25. Because all I need is another laptop and another desk and a bit bigger space. So the average cost can be the same. So this is describing industries that can compete with bigger competitors and smaller competitors, at least on cost, because they all have the same long run average cost. And it's just defined as constant returns to scale there. They mention real estate services. What does it take to expand your real estate office? Well, another desk, another laptop, and another salesperson. So they get these constant returns to scale within a certain period of output. And even then, you might get into the increasing or diseconomies of scale if you get too large. And the last example we want to show is that some companies, some industries hit their MES really fast. So at a very low level of output, their MES is achieved. And then if you want to expand any further, the costs take off phenomenally and you hit diseconomies of scale real fast, real soon. And they give examples like vegetable farming, dollar stores. I like to use an example of like a 7-Eleven corner grocery store. You know, they get to be a certain size. You don't see them much bigger. They've hit their minimum efficient scale. If they get much bigger, they would show really big increasing costs, because how are you going to get bigger on that real estate? You're going to maybe build another story or 2 stories. I mean, I'm being a little bit facetious, but that would be phenomenally expensive to try and make a big one in a small neighborhood. So they reach their minimum efficient scale pretty quickly. So that takes us to actually talking about minimum efficient scale. I kind of put the cart before the horse. We talked about it, understood it, and now we're drawing our first formal picture of it. And all I do is I look at my first plant size, AC1, and I find its minimum, and that's at that's Q economic capacity right there. And then we say, okay, well, what if we scale up our plant production? You know, we're seeing increasing returns to scale. Here is economic capacity for that plant. But notice the definition of MES finally in words. It's the smallest size plant capable of achieving the lowest long run average cost. So right here is my MEC. I meant to make that in green. So right there is my, not my MEC, but my MES right there. My color isn't changing to green, so I'm going to leave it red. The big dot is also my MES right there, minimum efficient scale. So those two occur at the same point. The QEC is on the red short run average cost curve, and the MES, the minimum efficient scale, is on the purple long run average cost curve. So remember, because there will be a multiple choice, it's the smallest size plant. That's what it means by minimum. So if you have a bunch of plants that all achieve lowest long run average cost, so they're all at constant returns to scale, like in the previous slide, you pick the smallest plant. That's the minimum efficient scale. That'll help you definitely with your Connect. So that's the end of this chapter, the end of chapter 7. We built the long run average cost curve. It's a fairly straightforward concept, and it's tied very closely to the short run average cost curves, right? They're married to each other. They're derived. One is derived from the other. So make sure, like I said before, that you have a really strong grasp of short run average cost curves and also understand the long runs, because we definitely use those short runs for the entire rest of the course where we talk about different market structures. And we'll see you when we get there.